6.6. We are looking at exponential and log equations. We're going to do a little warm up. I'm going to give you 3 problems. They are relatively easy. I want you to solve for x for each one. One, two, and 3. Gives me 16. 3 to the what power gives me 27. 10 to the what power gives me 4. So what is wrong? So we divide to Okay, what do we get for number 1? Show me with your fingers. 1, 2, 3, or 4, or 5. Okay, 4. Who wants to explain to me how they got 4? Well, I'm going to pick at random. Hawaii, how'd you get 4? So you knew that 2 to the 4th power gives you 16? Yeah. So you can say 16 equals 2 to the 4th power? I'm going to write it like that. What about number 2? Show me what you got on your hands. Okay, we got x equals 3. Anyone want to explain how they got x equals 3? You all just got it right. Who wants to explain how? The thinking process. Yeah? So you multiply 3 how many times? 3 times. So can I write 23 also has 3 to the 3rd power? Yep, and I got 3 to the x. Ooh, exponents. What about my last one? What's different about this one? It doesn't, so what do we have to do? Use the log. Yep. So how would I write this as a log? Log of what? 4 equals x. What's my base right now? Why didn't I write it, Mark? Yep, it's implied with the common log. You don't ever have to write log base 10. It's implied. It's common log. So when you type in the calculator, you can't write log base 10. It's just log. So, yep. What did you get for x? Yeah. 0.60. Keep going on forever. Yep. Okay, 0.6. That's fine too. 0.6 keeps going on and on and on. You couldn't have just gone that top of your head by using reasoning over here, right? Okay, so if, what do I call this 2 again when I talk about exponential functions? The base. So if these are the same, so if bases are the same, can solve it normally. Solve it in your head. Or, what can I set equal to each other? What do I set equal to each other here? When I went from here to here, what happened to the 2's? What? Yeah, what happened to the 2's? Say it, Sebastian? Angel, what were you trying to say? I didn't write them. So I set the exponents equal to each other. Now, if the bases are not the same, and I can't write them the same, I had to use log to solve. Now, those are actually both properties. And we're going to write them out. So the new one today is properties of equality of exponential equations. So properties of, oh, I don't like that. Properties of equality of exponential equations. So very similar to what I had above. I had 2 bases raised to a power. Call them x and y. And this is an if and only if statement, so I'm using the double arrows. Then I can set the exponents equal to each other. Yeah. Yep. I'll scroll. Good? Okay. So we just did that above. You've kind of been doing it the whole time. Just been thinking about it in a different way. Okay. We're going to do an example that's a little bit harder. Especially, I'm going to scroll down a little bit. Try this with your partners next to you. 2 to the x plus 1. Oh wait, do we want hard, medium, or easy? Okay, I'll give you easy one first and then a hard one next. Can you please solve for x?
That is the power. But what's it resting on? What's it like? What's the base on the right side? They have. Can you write either one power and? What I mean by that is you have the power written down. So on immediately our next line, this one, let's keep it basic. So right there, exactly. 2 to the power, same thing. And then instead of 4, that's 2 to what? So 2 to 1 half. Check that. Yeah, how do we write 4 at this time? It's 2 to what power? So we get instead of 1, right? Then and then what's the but so here we kind of blend ideas. We now have to what happened on the how it so let's go with assessment. Shoot it at
Okay, we'll start it now. Okay, I need the same base. So I need to change either 2 or 4. Which one do we change? Okay, thank you. Michael, go ahead. Okay, what? Tell me your logic.
So it becomes 2 to the 10, and that's how I found out that x equals 9.
I like it. So we're gonna talk through what Michael just did. So instead of doing 4, 4 you can also write as 2 to the second power, right? Yeah. 2 to the 10 power? No. We're gonna get there. But is this right? 4 equals 2 to the second power? Yep. Okay. So we wrote 2 to the second power because we want a 2 because we want the same base. 2 the fifth. X plus 1. So now we use power properties of exponents. And what do we have to do to not have 2 exponents? How do we combine them? Yep, we multiply. So we get 2 to the 10 equals 2 to the x plus 1. Now, Lily, I have the same base. What can I do next? Set them equal to each other. So we get x plus 1 equals 10. Julia, what do I do next? Yep, subtract 1. And we get x equals 9. Yeah? Thumbs up, thumbs down. Thumbs up, thumbs down. Okay, let's do a harder one. Guess what? You can now do challenge problem number 1 because you guys know how to do it. I think you can. Let's try 25 to the 3x equals 125 to the x plus 2. Same base. I just gave everyone a very good hint. Why? What did you say? Okay, let's try that.
But you can do 25. Wait, what?
Okay, show me with your hands. What did you get? Are we still working on it? Okay, keep going.
I think that works for the others. That's our two lane.
Okay, we changed this to a base of what? Okay, show me with your hands what was my answer. Okay, let's walk through this. What? Maybe, I don't know, let's see. So we're changing this to a base of 5, right? So, want base of 5. How do I write 25 as a base of 5? What was it? Yep. 232. 3x equals, what about 125? Yep, 5 to the third equals 125. So x plus 2. What's my next step? Properties of exponents. Yes, distribute. So what do I get for this side, Sebastian? 6. Yep. What about my right side? Brent, what did you get? That's it, just 3x? Plus 6. Yes, gotta distribute it to both things. I have the same base, Michael. What you looking at? No? Okay, what do I do next? Sunny, what do I do next? Okay, which way you want? Minus 3? Okay. So then I have 3x equals 6. Amy, what do I do next? And what did you get as your answer? Here. Yep, x equals 2. Did I lose anyone anywhere along here? Chetty, how you doing? Yeah? Did I lose you anywhere? No? Perfect. Okay. Sunny, you good? Yeah? Okay, I'm gonna give you one more. X, I don't know. I'm gonna give you 2x equals 7. What? New problem. What's our first thought? Why am I doing log? They don't have the same base and I can't change it to anything like that. So I'm taking the log of both sides. Do you remember when we used to do this? Literally yesterday? Yep. So what am I doing right now? The change of base. Yep. So walk me through it. What do I have to do first? Liam. I can't divide yet. I gotta do something first. Yep. Where did I put it? Yep. X times log of 2 equals log of 7. And then I can divide by both sides of log of 2. Yeah. Yeah. Okay, let's do ln. ln of 2x equals ln of 7. Okay, wait, this was my final answer for this one. And then I'll do ln. This was the final answer for this one. So, Naomi, if I'm doing ln, what do I have to do right here to simplify it? Yep, take the x out. Equals ln of 7. Now I can divide ln of 2 from both sides. And I get x equals ln of 7 divided by ln of 2. This is what we did yesterday. Pretty sure you did very well on this on the homework and on the boards yesterday. Yeah? Are these the same answers? Yeah? What do they both equal? 2.80. Keep going. Okay. It keeps going. It keeps going. It doesn't matter if you use log base 10 or ln. That's totally fine. Okay. We actually just did a property, which you guys have been doing the whole time, but we're going to put it into words now. So I'm shifting it over. We're going to do properties or property of equality of logs. Log equations. So we were doing this yesterday without actually knowing the property. So this says if log base b of x equals log base b of y, so same basis, then this implies, with an if and only if statement, that x equals y. We've been using it the other way most of the time. So when we've been saying x equals y, then we've been taking the log of both sides. This is not new. We did this yesterday. Problem we just did it. So if I give you an example, and it was 5 to the x equals 11, which property do you think we're going to have to use? Yep, because our 5, yeah. Say it, Angel. The property of equality of exponential equations? Okay, you want to use change of base. Yep. So you can use the change of base in this one. So you have to take the log of both sides. You don't have to do this problem right now because we're going to do it up on the boards in groups with a lot more problems. Yeah. What? Yeah. Okay. When you do the change of base, you most of the times pick log 10 or ln. It does not matter which one you do. So when we were doing the example, did we all write this? Yep. So up above, we did both sides and they both equal the same thing. It does not matter which one you do. Whatever one you feel more comfortable with. Okay. Let's do our groups. That's not it. Those are the problems. Okay, who wants to be in the same group together? You and who? You and Mark? Okay, let's see if you guys are in the same group. Because I already did your groups. Okay, ready? You guys aren't. I'm sorry, guys. Maybe next time. These are your groups. What? I don't know. Oh, find your boards. Number 8 is on this board. My bad. Oh no.
Oh no, it is now.
Okay. I'm just gonna write them on here because I don't have it up there. First one is 5x equals 11. Second one is 6x plus 2 equals 17. I will keep writing the rest of them, but stop going. Yes. That's fine.
I did the first one in my notes.
What was the answer? What's X?
Well, we should probably write the It's 1.49.
Will we use six for that? Like similar?
Like you have to more.
Like since we are gonna need like two, like similar, will we use three first?
Make sure you.
Why would you use 3? 17 is what's it? No, they could. But like, hey, what do you think? That's 1.49.
Wait.
Bro, where'd you go? Well, 17 can't break down
Yeah, breakages or something.
Yeah. So, unless we can actually figure out if 6 can get to 17. Make that. Oh, we're doing the log thing, but there's different bases. That's there's different bases.
Yeah.
That's why you do log. You only do the yeah. That's how we do log. Oh. Oops. Log.
huge question for you. I don't want to interrupt. What moved to the front that's going to multiply by log 6?
Would it be like
What did you have multiplying by log 6 on your next line?
2.
You had just 2, right?
oh
Yeah.
But what multiplies 2?
Oh.
And how do you fix that notationally? Huge difference. Are you going to divide by the same thing? Okay.
Wait, so why would we keep 2 in the front and like get rid of x?
Connected to. I think we would divide by just log and 6. Yeah.
Yeah.
So we haven't done it yet.
Why? Yes. Minus is never gotten.
I got positive.
Yeah, but we still have to
Oh,
subtract
shoot.
2.
Wait, minus 2 like that. Yeah.
Yeah, and then when we get x negative 0.419.
Wait, what did you say?
Negative 0.419. Nope, it's my Oh, okay. All right. Ronaldo.
Sitting here if you guys both want.
I think this is the one where we changed the. Wait, where's the one?
Wait, did I skip?
No. I skimmed it.
But
Oh, I was gonna. I thought it was
Oh,
we
can
start
we
outside,
do
right?
3?
Yeah, we can do.
X equals 3? Yes. I mean, no, not 3, 2.
2.
Okay.
Oh, sorry. Which one? Are we on?
What's the difference?
So. Equals guacamole. 2.
This one we do.
Will we use base 16 or base?
I think we can because but 16 wait base
my
2
markers and stuff, my whole order said it was delivered on the 30th.
Base 2. Oh, yeah.
We have
Wait, so are we
We
gonna
can make 16 base 2 here by
Yeah,
making 4. I mean, 2
2 to the
to 4.
2 to the x to the 4
Oh,
or is it
2 to the 4. X. Maybe? I think.
but don't we keep the
I should probably not.
the old exponent inside of the parentheses one but the
Okay.
Yeah, you can put the X outside.
So should we do log 16? I mean log base of 16 or log base of 4?
no just 2 what
Wait, no.
no like we're gonna change it to this like we were just doing so how we change like the other
So like or log different. Sorry.
Because 2 to the power 4 is 16, so we're not really. Do you get what we're saying?
So only so sorry.
No, it's okay. Just write 2 to the power 4. Write that. And then on the outside is an X.
What's next?
No, an X. That's an
like
exponent.
exponent or
Like a power.
Yeah.
Okay, then equals the.
the same thing
Oh, so-
No. Equals that.
oh.
It's a 2.
wait 2 like this entire
Oh.
2
Oh, all of it?
yeah 2 to the 3x and then we can put 4x
I had some other meeting.
equals 3x plus 4
Yeah.
On your, are you guys set up where you just have
and then minus 3x on both sides
here? What is actually multiplying by 1/7?
the x equal to
What is written to be multiplied by your lot set on the board?
Yeah, x equals 4.
yeah.
Because you're right, but that's not what's written.
And then, yeah.
On the right side of that equation, the very last thing you
And
have.
then number 6. Yeah, I think this pen's mine.
Well, how do we make it so it's? Yeah, well, sort of. I've seen if I can put it. Go check with Parker. Why don't you go look at how they're doing? You know what they're doing? They're doing number 6. Same one.
Did we just do this?
So what they've done, there's
Or
notation.
something similar?
That's what's killing you.
Log 3x. Log.
You're great.
That would mean we have to move the 3x out.
Oh, shoot.
Yeah, so I don't know.
They went 3x. Equals
Like just
x plus 1.
Makes sense. Could we move stuff and combine like terms, like the 2x plus 1 and the 3x on one side?
Oh, right. So that's just x
Oh, yeah.
on 2.
Equals 1, but we can move both 1 and or
Oh, they changed.
1 plus.
Is one like an invisible one?
Makes sense.
I don't think there's an invisible one.
I think we have to put the 1 on the other side.
So it's x plus 1.
Yeah.
Oh, wait.
I think. And now,
Wait.
well, let's ask if if there's a 1 kind of a log, is it like invisible or you have to add it? Point to this invisible one. Okay, cool. That's just the regular one.
It's just a regular one?
Okay, but what do you want to do? We want to move all the x's to 1. Okay. There's a step you have to do. Oh, here.
3x log. How do you distribute this? Like
Oh,
this?
could we?
Wait.
Oh, can we solve for that and then add it on and distribute it to the thing?
Are we all getting caught up on?
Like you make
Right,
you
you want
find
to
this
sit
on the
down?
calculator and you distribute it to the thing.
Oh.
That one.
No?
No, we're gonna solve for the logs and then distribute it to each one.
This is what I got for everyone.
Log 7, show it to me.
Oh, okay.
Oh wait, can I see your calculators here? Times 2 plus 1.
Oh,
Can I, I'm gonna give, are you guys?
Is that would be on this one?
Yeah.
Okay. Yeah, I'm gonna watch to make sure that that's true.
Wait.
How do we put? Oh wait, maybe we only need it to one side.
Oh yeah.
3x log
2.
Oh, and then we just divide.
If you're not gonna write all 8
Divided
decimals
by
for y, I would keep it at log 6.
Log
I wouldn't round this early in the problem.
Yeah. You want log first and then y.
let's aim for multiplication.
Well, we didn't run our calculator.
What's the divided?
You did it
2.9. How'd you get 2.9? 2.89? Yeah.
6.9?
6.9, yeah. We did log 7 and then we distributed log 7 to the 2x plus 1.
Is that what you meant?
I was wondering what it was. I didn't think about doing it that way. Okay.
Still gonna give us the.
I don't know. But okay. I didn't even want to figure out the rest of it.
Thank you.
Group 5 and group 6 have two different answers. What do you have?
Wait.
Okay, so you switched a lot of numbers. Okay. Why don't we sit down and we'll stop going through it?
Thank you.
You're welcome. For what, Ronaldo? Putting you into a group? Making you work? I'm good with that. Oh, I didn't pause this. Okay, Angel's group, what was your first step in this problem? I don't know.
We did ln of 7 over ln of 2, and then we got that 0.8074. And then after that, I just replaced 7 to 2 to that number, and then distributed the 2x plus 1 to it, and then got those numbers, and then set them equal to each other, like the exponent, and then solve for x.
Okay. That's a lot. This group, who was here? Ronaldo's group. That's the only one that raised his hand. Okay, what was your first step? Okay, you took the log of both sides. I'll tell you that because it's right here. I have 2 to the 3x equals log 7 to the 2x plus 1. Okay. I have logs with exponents. What do I have to do? Yeah, power property. So I'm taking them out. So I got 3x times what? Keep going. So 2x plus 1 equals the log of 7. Now at this point, you guys went on very different paths to solve this problem. Yes, I'm going to write this in blue. I'm going to distribute this log of 7 to both of these values. Okay, because what's happening in between 2x plus 1 and log of 7? Multiplication. So I can't just subtract all this and move it over there. Okay, I'm trying to isolate x all by itself. So I gotta separate it. So I have 3x log of 2 gives me 2x log of 7 plus, well, log of 7. Okay, I want to get x's all together. What can I do now, Liam? Yep, so I'm moving what? Just this one? Yep, 2x. Move it to both sides. I'm going to write my statement here. And you are going to finish this problem for homework. Take a picture and write it down of what you wrote on the board. But I'm at this point in my problem. We'll go over the rest of it tomorrow. What's up? Yeah. I'm not going to tell you till tomorrow. You're going to ponder. Is there a way to check it? Okay. Sure. I can give you that. Hmm.
Alright, here's the deal. I'm not your teacher for second hour during elections, so I'll tell you if I see any kids up in the stands, like texting and stuff, whether you're in my class or not, I'm gonna come take your phone and your folks are gonna have to get it. You can record speeches, don't be texting and stuff.